Hello everyone, my name is Parmita Heydari. Today we are going to learn config maps and secrets in Kubernetes. Config maps are an API object in Kubernetes that can store non-sensitive data as key value pairs. This enables applications to consume configurations separately from their codes. Config maps can be created from files, directories, or literal values and can be used by pods as environment variables. There are 4 different ways that you use a config map to configure a container inside a pod. Inside the container command and X environment variable for a container, add a file in read-only volumes for the application to read, write code to run inside the pod that uses the Kubernetes API to read a config map. Here there is an example. The following config map stores 2 properties, username and access level, and the following pod consume the content of config map as environment variables. Let's create our first config map. Here I have a config map YML file. I define 2 environment variables, greeting and farewell, and also my pod here using the Alpine image, and by config map ref I refer to my config map, kubectl, apply. I create a config map and a pod by running kubectl get config map. I can see my config map, which is here in default namespace, and by running kubectl get pods I can see my app pod. Let's exec to my pod and see whether the environment is set or not. By running kubectl exec with the name of pod, by running n, we can see all environments in the pod, and here is farewell and also greeting. Let's take a look at secrets in Kubernetes. A secret is like config maps, but it is designed to hold sensitive data, such as passwords, tokens, or SSH keys. Secrets are encoded in base 64 to protect them from being easily readable in plain text. Kubernetes provides mechanisms to manage these sensitive data securely, allowing them to be consumed by pods as environment variables or mounted as files. Secrets also can be created from files or literal values. Kubernetes provides several built-in types of secrets, like opaque, which is user-defined data, service account token, Docker CFG, Docker config JSON, basic auth, SSH auth, TLS, and token. Let's create our first secret. By running kubectl create secret, I create my first secret from literal values. By running kubectl get secrets, here I have my secret, and by running kubectl edit secret, my secret, we can see that here it is in base 64. And if I decode this value by running here, I decode it. This is the exact value. Before finish this session, let's take a look at readiness prop, liveness prop, and a startup prop in Kubernetes. Liveness prop. This prop checks whether a container is still alive and functioning. If the liveness prop fails, Kubernetes will automatically restart the container, helping to recover from situation where the application is stuck or unhealthy. Readiness prop. This prop checks whether a container is ready to handle requests. If the readiness prop fails, Kubernetes temporarily removes remove the pod from the services endpoints, ensuring that traffic is only sent to the pods that are fully prepared to process it. A startup prop. This prop is used to determine if an application within a container has started successfully, allowing liveness and readiness checks to be disabled until it is success, which is useful for slow starting applications. How to do resource management in Kubernetes. When you specify a pod, you can optionally specify how much of each resources a container needs. The most common resources to specify are CPU and memory. By defining requests and limits. A request refers to minimum amount of CPU or memory resources guaranteed to a container, ensuring it has the necessary resources to run, while limits define the maximum amount of resources that a container allowed to consume. When a pod uses more than resources than it is defined, the kubelet evicted to free up their resources. Look at the example here. I have a pod, and by defining requests and limits, we define how much resources this pod needs. Let's take a look at QoS classes in Kubernetes. QoS, which is short form of quality of service, in Kubernetes categorize pods based on their resources. There are 3 QoS classes. Guaranteed. Pods in this class have equal resource, request, and limits for all containers, making them ideal for critical applications. Burstable. These pods have at least one container with a resource request that is less than its limit, allowing them to use additional resources when available. Best effort. Pods classified as best effort do not specify any resource requests or limits. How to schedule a pod on a specific nodes. There are 3 different methods that you can define to schedule a pod on a specific nodes. By defining node selector, node affinity, taint, and tolerations. Node selector, a simple way to constrain pod scheduling on specific nodes. Labels must match for the pod to be scheduled on a node. Node affinity, a more flexible scheduling constraint that allows specifying rules about which nodes or pods can be scheduled together based on labels. Taints and tolerations. Taints are applied to nodes and tolerations applied on pods. It prevents pods from being scheduled unless they have matching tolerations, allowing for more controlled scheduling based on node conditions. I hope you enjoyed this video. Let me know if you have any questions.